Welcome to my YouTube channel Janit for the JEE and NEET aspirants. The distance of center of mass from end A in one dimensional rod. Okay, so one rod is there. So the distance of center of mass of one from the end A of one dimensional rod AB, whose mass density is given, and the length L. Here L is basically denoting the length L. So the center of mass is basically given as a 3L by alpha meter. That means now you have to calculate what is this alpha value. Okay, so the variation of linear mass density they have given. So the question is, instead of lambda they have used some different, we can say that variable q. So q naught 1 minus x square divided by L square. This is a linear mass density, and this is your rod. Okay, so this is A and this is B. From A, what we will do, we will consider small element dx, having length is dx at a distance of x, and you know that how to calculate the dm mass, lambda into dx. Instead of lambda they have used another notation q, no problem. So q into dx. X center of mass, if you calculate, what you will do, x into dm divided by integration of dm. Fine. So dm, you already know q into dx, which is nothing but q naught 1 minus x square by L square. This is nothing but dx. Now you have to integrate. From where to where you will integrate? The total length of a rod will be L. That means this is 0, 0, and this will be L, comma 0. Okay, that means it is varying from 0 to L. So from 0 to L, x into q naught 1 minus x square by L square dx divided by, again the integration is 0 to L. What is this dm? Dm is nothing but q naught 1 minus x square divided by L square dx. So what you have to do, you have to only integrate. Very, very simple. Okay, so this q naught will be cancelled out because this is a constant. So x dx integration is x square by 2, and the upper limit and lower limit is already given. Okay, so if you simplify, what value you will get? This is x square by 2. Now this is x and this is x square, x cube. Then x cube integration is x to the power of 4 divided by 4, and this value will be L square, and it is varying from 0 to L. What is the denominator? So x minus x cube by 3 L square. X square dx integration is x cube by 3, and it is varying from 0 to L. You just put the upper and lower limit, you will get the x center of mass. So x center of mass means this is L square by 2 minus L square by 4 divided by L minus, this will become L by 3, because L cube by L square is L. So L square by 4 into this 3 divided by 3L minus L is 2L. So you will get as 3L by 8. Okay, now you can compare what the center of mass they have given, 3L by alpha. Now they are asking what is the value of alpha. Alpha is nothing but 8. That means alpha in this question, it will become 8. Very, very good question. Okay. Now let's move to the next question for a composite system, how you will approach. So this is also a JEE problem. In 2020, they have asked the coordinate of center of mass of a uniform flex shaped lamina of mass is 4 kg. That means for the complete mass is given as 4 kg. Okay. So if you divide this particular flex into two sections, this is first section and this is second section. Okay. So if you see, this length will be 0 to 2 means 2, and this will be 2 to 3 means 1. So 2, 1. Similarly, here is 1 and here is 2. That means if total mass is 4, can I say this mass will be 2 kg, and this mass is also 2 kg. Okay. Now for calculating the RCM means the center of mass x and y coordinate. So as you know that I have already talked about, when the two bodies, or we can say that for a composite body, the center of mass is m1, r center of mass of first, m2, r center of mass of second. You can also calculate individually as xcm and ycm, and then you can check the answer. I'm discussing this question in the form of vector. So M1 mass, so M1 is 2 kg. What is RCM? That means in terms of vector, what is the position of center of mass? This is nothing but position of center of mass. Can I say 0.5 and 1? Because this is 1, so 0.5 is the center. And what about this? This is 2, so the y coordinate will be 0.5 and 1. Now, for the center of mass of this second body, can I say this will be nothing but 1? X will be, this is 2, so this is 1 center of mass. What about this y coordinate from this origin? So as you know that this is completely 2 and this is total is 1, so this value will be 0.5. So that means 1 comma 2.5, 1 comma 2.5. So now the problem is simple. So 2 RCM, can I say in terms of vector it will be half of I cap, that means plus, what about the second one, M2 mass? Let me first write for the RCM one only, J cap plus M2 mass is 2 into, what is this, I cap plus 5 by 2 J cap. Okay, so you can also calculate XCM for M1 X1 and plus M2 X2 and for YCM, but I have discussed in a vector form, so it will reduce your calculation. Okay, M1 plus M2. What is M1 plus M2? 2 plus 2, which is 4. Now you can simply solve this. So this is nothing but 3 I cap plus J cap. If you want to calculate, this is 2J and this will be cancelled out. So 5J, that means 7J, 7J cap divided by 4. That means this value is 0.75 I cap plus 1.75 J cap. This is nothing but the position of center of mass in form of vector. Now you can compare, this x coordinate will be 0.75, okay, and 1.75. That means option C is the correct. Okay, if you consider XCM, that means you have to use M1 X1 plus M2 X2 divided by M1 plus M2. Now you have to write down for YCM. So I have solved in the single vector form. So that means the correct answer for this question is option C. Option C. Option C. Okay. Now let me take one more problem. So this is also a JEE problem 2019. Uniform rectangular thin sheet ABCD of mass is M and has a length is A and breadth is given as B as shown in figure. If the shaded portion HBGO is cut off, the coordinate of center of mass of remaining portion will be. That means you are taking a small portion HBGO from the complete uniform thin sheet, then you have to calculate what is the we can say that the center of mass. You already know, for this is basically first of all a negative system. Okay, so in negative system you have to use the minus sign, fine. So what we will do first? So first of all we will check the, this is complete first one as the red color which I am showing here. This is the first body. Now the second body is nothing but the cutout section, which is this one. The second body, which is nothing but this cutout section. Okay, this is nothing but the second body. So this is first and this is second. So A1 is area of complete sheet, area of the complete sheet. So area of complete sheet means area will be A into B. A2 is the area of cutout section, area of cutoff section. What is the area? A2 value is, this is nothing but A by 2 and this is also B by 2. So we can say that it is AB by 4. Area you have calculated. Now the thing is, you have to first find the center of mass of the first and second body. The center of mass is this one, which is already A by 2 and B by 2. What about the center of mass of second? So this one. So this is basically A by 2. So what about this one? This is total is A by 2. So A by 4. So A by 2 plus A by 4. Can I say this point is nothing but coordinate is 3a by 4. Similarly for y also, this is nothing but the a by 2 and b by 2, and this is nothing but the b by 4. Again you will get as a 3b by 4. So now you have calculated the centroid of the first and second body. So now you can use the center of mass for a composite system. Okay. Now if I want to calculate the x center of mass, can I write a1 x1 minus a2 x2 divided by a1 minus a2. Why we are using minus sign? Because we are subtracting some of the portion. If we will add, then we have to use the plus sign. Similarly, ycm is nothing but a1 y1 minus a2 y2 divided by a1 minus a2. Okay. So this is nothing but area is AB. X1, let me check, a by 2, b by 2. This is a by 2. A2 is A2 area is AB by 4 and 3A by 4. AB by 4 and 3A by 4 divided by AB minus AB by 4. Once you will solve, you will get 5A by 12. Similarly, for y center of coordinate, area is same only, that is AB, and here also AB minus AB by 4. Now check the y coordinate, B by 2 and 3B by 4. So B by 2 minus AB by 4 into 3B by 2. Sorry, 3b by 4. Okay, so once you will solve, again you will get as 5b by 12. Okay, so the center of mass for this rectangular thin sheet ABCD, when you will take a small portion which is HBGO, you will get as option D is the correct answer. Option D is the correct answer. Okay, so I have discussed how to calculate the center of mass of point mass when there is a distribution of mass for the area based, volume based, as well as the we can say that as a linear, one dimensional. Okay, then I have talked about some of the JEE problems, how to approach for calculating the center of mass.